Okay, YouTube, in our last video we looked at the basic shape and characteristics of the graphs of cosecant and secant based upon the graphs of sine and cosine respectively. And what we discovered was basically to graph cosecant and secant, all we need to do is graph the parent function first in order to see where the zeros are and determine basically where we put these asymptotes. And we can see that between the asymptotes we have these green little swoops here that come in and either touch the crests or troughs of the original sine or cosine function. So what we're going to do in this video is going to put together a couple of graphs of secant and cosecant functions and take a look at how the graphs of their reciprocal functions are very helpful in doing so. So let's go ahead and do this. For number 2 here, it says identify the amplitude, period, and starting point for the graph. Then construct our frame and graph 2 cycles of the function. So we're going to start by graphing one cycle first, and we have the graph of y equals 2 cosecant of x. So the first thing that I'm going to encourage us to do is to rewrite as the reciprocal. Because what we're going to do is we're going to graph its reciprocal function. Essentially we have y equals 2 cosecant of x. This would be the same thing if it were a reciprocal as y equals 2 sine of x. And so we're just going to rewrite it as the reciprocal and go graph this instead. And so if we're going to graph this, let's go ahead and do what we do when we graph. We identify the values of a, b, c, and d. It seems in this instance here we have an a value of 2 and it's positive, so no reflections here. We have a b value, a coefficient of x of 1, so we say 1, and it seems that we have no c or d value here, so no horizontal or vertical translations, which is kind of nice when you're kind of starting down here. So let's go ahead and graph this 2 sine of x. It itself would have an amplitude. I'm going to write this over here. An amplitude of the absolute value of 2. And so we get 2. Its period here. Remember the period of sine is 2 pi. So 2 pi over the b value, which in this case our b value is 1. So we get a period of 2 pi in this case. So that'll give us the length of our frame. We have a height of our frame. Now let's find our starting point. Remember that our starting point is at c over b comma d. So our c value being 0 is kind of nice. C over b, 0 over 1, comma d, it looks like our graph is not going to be shifted as we kind of already have mentioned. So we say 0, 0 is where it's going to start. So with respect to graphing this, let's go ahead and say that we have some graph here. I suppose I'll extend out into the right and to the left here. We're going to start with our starting point, which is at 0, 0. I'll put a little box here to indicate that we're starting at 0, 0. So let's get our height and our length of our frame in here. So the height of our frame looks like the amplitude is 2. We're going to go up to positive 2. We'll proceed down to negative 2 here. And then we'll also go out to the right. It looks like we need to add on 2 pi units to this. So if we're already in an x value of 0, we add on 2 pi. The nice thing is we're stopping at 2 pi. So we can see that our frame exists here. Go ahead and extend this outward. And we'll partition our frame. So we'll get our midline in. And we'll split this in half. We need to label this. So that would be the average of 0 and 2 pi is pi. We'll split those halves in half. So this would be here. I'm going to say that this is pi halves. And this would be 3 of those pi halves. Okay, so with our graph, basically what we're going to do is we're going to graph in our sine function. We have a non-reflected sine function. So I'll go ahead and do this. We know that sine starts at a 0, goes up to its max, goes to a 0, goes to its min, and goes to its 0 again across its period. So we'd say here's our basic sine curve with basically an amplitude of 2. That's the only difference between our parent function and this. But what I want you to understand is this. I'm going to switch colors in ink here. We'll switch over to a red. What we wanted to do was graph the cosecant function. So with respect to the cosecant function, here's why we graphed this in the first place. Because we know that wherever this is at a height of 0, we know we're going to get something that's undefined. So I'm going to go ahead and I'm going to put in asymptotes. First things first. We're going to put in asymptotes wherever our original relation would be at a height of 0. You know, I've had people ask me, do I really need to draw in the original sine curve because I already know it's going to have zeros here? Can I just go ahead and put in the asymptotes? I say, yeah, just go ahead and do that. You know, the other thing is this. Because when we reciprocate, these swoops here will be at the same height on our reciprocal function. We could just put in dots right where those crests and troughs are, and we'll put in our u's. Now, this is important. Our u's stay inside these vertical asymptotes. But basically, excuse me, what we get is this graph that you see right here. And so with respect to what we see a couple of key points. I suppose that this would be a minimum, a relative minimum right here. And this point right here would be a relative maximum. But there would be no absolute maximum or absolute minimum for this graph right here. And with respect to, I suppose, domain and range, you know, you're going to see it written all sorts of different ways. I suppose in this respect, you know, our domain would just be all real x values except for where these asymptotes exist. And our range here would be all y values, I suppose, so long as they're greater than positive 2 or equal to positive 2 or y is less than or equal to -2, down below -2 here. So let's go ahead and take a look at another graph here. We'll take a look at a secant graph. And so what we want to do here is graph secant. First thing we're going to do is the same thing we did in the last one, which is go ahead and graph its reciprocal function. So it's reciprocal. If we were to graph the reciprocal here, we would have y equals -3 cosine pi x. I'm going to try to remember to graph 2 cycles on this one. We forgot to do that up there. But if we're going to graph this here, we have a is -3. It looks like our b value here is pi. Interesting, pi. This happens. And then again, c and d. So no translations on this one. We have c and d are 0. So if we were to graph this one, we'd say the amplitude is equal to the absolute value of -3. And then the period here would be 2 pi over b. So we say 2 pi over b. Our b value here is pi. So our pi's cancel out, we just get 2. So we have the height of our frame is 3, the length of our frame is 2. And so we could also say the starting point is at c over b comma d. So we have c over pi, 0 over pi, comma 0. So we say 0, comma 0 is our starting point. We can go ahead and graph this guy here. So now, graphing this, let's go ahead and get our axes in. Suppose we could see that, I'll extend this out to the left a little bit further here. Disjointed, I apologize. We're going to start at 0, 0. We'll get the height of our frame in here is 3, so we're going to go up 1, 2, 3, call this 3. We'll go down to -3, we'll call this 1, 2, -3. And then the length of our frame here, we'll just call this how about I bring it in a little bit here, we'll call this 2. So we have our frame. We're just going to lay in our cosine graph is all we're essentially going to do. So let's get our partitions in here. This would be 1. We would have 0.5 and 1.5 here. I'll leave it to the viewer to fill those in. For right now, I just want to keep this not very crowded. But what we've got is a situation where our cosine graph, where it would be reflected here, would instead of starting at its maximum, start at its minimum, proceed to a 0, then go to a maximum, proceed to a 0, and then come back to a minimum. And so we would get this original cosine function that would look something like this here. And so again, I'm going to grab a different color ink. How about back to a green? And what we're going to do is the first thing immediately we're going to do is we're going to highlight wherever this graph would be at a height of 0. And so I'm going to take those boxes out, but those are what we're looking at, and we're going to drop in asymptotes wherever this original reciprocal function is at a height of 0. So we'd say, here we go. Dropping in these asymptotes, we could say that then the reciprocal function itself, this secant graph, would just be these swoops in between our asymptotes here that pass through the same crests and troughs as our reciprocal function. And so we would get this graph that looks like this. And so remembering this time, we have to graph 2 cycles of this. We're really quickly, let's go ahead and drop in out to -2 here. We can just extend our frame. This is all this means. Drop in our partitions. So this would be -1 here. -1.5, -0.5. We'll get our cosine graph in over here first. We want to do our reciprocal function first. So here's our roundabout reciprocal function. But again, we could see that asymptotes would exist wherever the original reciprocal function is at a height of 0, and then we could drop in these swoops in between. So really cool, really cool. I know what you're thinking, so I'm going to say it. Basically, all you got to know how to do is graph a sine or cosine graph. So one thing I want to make sure I comment on before we peace out on this video is something that I didn't mention prior to this, but basically, it says amplitude, period, and starting point for our secant graph. And what I want everybody to know is that our starting point on these original 2 functions that we saw here and the one that I scrolled off of here, the starting point of the reciprocal function was 0, 0. So the interesting thing is that 0, 0 is still the starting point, no matter if you're looking at the reciprocal function or not. So with respect to period, also, the period of the graph is how much input or x value you have to go through one full cycle before you repeat yourself. So we can see, for instance, the period of this graph, the sine curve was 2 pi. It looks like this pink curve where we have an up u and then a down u. That would be one full cycle right there. So the period of our reciprocal functions is the same as the period of the parent function. So the period here would be 2 pi because the period of its reciprocal function was 2 pi. The period down here, well, this was 2 pi, so the period here is 2. And so the last thing we're going to say is that there is no amplitude on the reciprocal function. Now, curious, we'd say that there's an amplitude on sine and cosine. Why isn't there an amplitude on cosecant or secant? And the reason why is because the definition of amplitude is half the distance between the maximum and the minimum. And when we look at this graph here, analyze this magenta graph, we see that it has no maximum and no minimum. And so because of this fact, we say that there is no half distance between positive and negative infinity, and so therefore the only curves, and I'll just go ahead and share it now, that have amplitude are going to be our sine and cosine curves. Cheers.